Hello and welcome back. This is the third and final video on dot product, and today we're going to talk about how to use the dot product to find length of projection. Now, the first thing you might ask is, what is projection? If you're to go out somewhere in the sun, your body will cast a shadow on the ground. And one way of saying this is that a shadow is a projection of our bodies. Now, in vectors, we have something similar, right? So instead of having your body over here, you can think of a vector V, right? This is similar to your body. Okay, and if you have light coming down from the top that is parallel, this will cause V to cast a shadow over here on the ground. Instead of saying ground, this is slightly different. We're going to have a vector traveling in the direction along the ground. Okay, a vector traveling along the direction of the ground. Let's call it U. Okay, then we can say that vector V is projected onto U, just like your shadow is projected onto the ground. And the formula for this will be the length of projection is that V will be casted in a way onto the direction of U. Remember that the unit vector actually really represents a direction, so we want to cast V into a new direction. So it's V dot U cap with a modular sign because we're talking about a length, scalar quantity. It has no direction. Okay, so this is the formula for length of projection. As usual, we'll have a practice question to wrap this all up. This is the practice question for today. You know the drill. Pause the video here and give it a try. Welcome back. So for the first part, we need to show that 3a minus b, which is a vector, dot with a plus 3b, another vector, the dot product of these two vectors is equals to 8 cosine theta. But we're not given explicitly the column vectors for a and b, which means I need to expand brackets. A and B are unit vectors, which means mod A is going to be 1, mod B is going to be 1. And very nicely, this will be 3 times 1, and this is minus 3 times 1. That will cancel out. So what I have left is 8 times of A dot B. And now I'm going to use the geometrical definition of dot product. And again, you find that mod A mod B is equals to 1. So this is equals to 8 cosine theta, and we have managed to show what is required of us. Welcome back. Now we have to find the length of projection of 3a minus b onto a plus 3b. Now remember the analogy I gave earlier on? We're always going to cast a projection of a shadow onto the ground. So we can think of this as the vector that runs along the ground. And remember the formula for length of projection? It's going to be vector v, which in this case is our 3a minus b, dotted with the unit vector of the vector that runs along the ground, which is the unit vector of a plus 3b. So perhaps first I would like to find the unit vector of a plus 3b, which means I need to find the modulus of a plus 3b. So to find the modulus of a plus 3b, this will give me the modulus of a plus 3b squared. Now again, I have to do some expansion of brackets. Remember that a and b are unit vectors, so mod a square is 1 and mod b square is also 1. In this step, I've changed a dot b into the geometrical definition, mod a mod b cosine theta. We are also given in this part of the question that theta is equals to 60 degrees, so that's cosine 60. Now cosine 60 is equals to half, and a and b is equals to 1, so this is equals to 3. Which tells me the modulus of a plus 3b is square root of 13. Great. Now let's put this working aside. Now I can go ahead and find the length of projection. There's going to be a modular sign, and I'm going to take 3a minus b and dot it with a plus 3b. But this a plus 3b has to be divided by the mod of a plus 3b, which is square root of 13. What I have here is my vector 3a minus b being projected onto the direction along the ground. Right, this is a unit vector. Okay, great. And we can make use of the first part. We already done this before. 3a minus b dot a plus 3b, that is 8 cosine theta. Alright, and remember cosine 60 is half. And we have managed to show what is required of us. And that is the end of this question. So I hope you found this video helpful. And in the next one, we're going to look at cross product, another very versatile tool in our toolbox for H2 Maths vectors. So until then, I'll catch you on the flip flop.